Let's take a look at our fourth example, graphing an inequality in two variables. So we got 3x plus 5y is greater than or equal to negative 2. Now, first thing we're going to do is we're going to solve for y on this. So I'll take 3x over the right side, becomes a negative 3x minus 2. Then divide everything by 5. There we go. And we get y is greater than or equal to negative 3/5 x minus 2/5. Now, really, I think it's easiest to have it in this form, where you have it solved for y, whether you're doing it by hand or whether you're using a calculator. First thing we got to do is graph this. Now, if it's in this form, if I did have an equals here, this would be slope-intercept form, which means the negative 2/5 would be our y-intercept. Negative 2/5, I don't know, maybe about right there. And then the slope would be negative 3/5. And negative 3, let me write that down. Slope is negative 3/5. The negative 3 would mean down 3, and the positive 5 would mean right 5. 4, 5. Okay, so down 3 and right 5. I go 1, 2, 3. Right 5 would be about right there. So we graph the line just like normal. Now, if you have a greater than or equal to, or less than or equal to, you're going to have a solid line. If you have a greater than or less than, it'll be a dotted line. Well, this particular problem is greater than or equal to, so it's a solid line. Now, at this point, we want to pick a test case when doing it by hand. And it doesn't matter what point you pick, just as long as you can tell for sure it's on one side or the other. I'm going to pick the origin, which is right here. And what we do with that is we plug it into our inequality. Now, it doesn't matter where you put it in at. I'll put it in the first one. So I got 3x plus 5y is greater than or equal to negative 2. So I got 3 times 0 plus 5 times 0 is greater than or equal to a negative 2. Now, at this point, this is more of a question mark. We don't know if it's greater than or equal to. 3 times 0 is 0, 5 times 0 is 0, 0 plus 0 is 0. And we get 0 is greater than or equal to negative 2, which is true. It's greater than. Since this is true, that means we'll shade the side where that test point falls. Falls on this side, so we're going to shade this side. Now, if it had been false, like what we come up here is false, then you'd shade the other side. Well, on the calculator, these are very, very straightforward. If you have a greater than or equal to, you want upper right triangle. If you have a less than or equal to, it'll be a lower left triangle, like that. Now I'm going to graph this just like normal. So I'm going to come here, and this is the one I want to plug in my calculator. So I got negative 3/5 x. Press y equals clear. Negative 3 by 5 x minus 2/5. So minus 2 divided by 5. And then I'm going to press my left arrow key until I can't press it anymore. We want the flashing cursor on the slash in the far left, very far left of the y1. There it is. See how my flashing cursor is now on that slash? Now push enter one time. It becomes thick slash. I press it one more time, becomes an upper right hand triangle. Now the one we want for this problem is we've got a greater than or equal to, which means we want the upper right hand triangle. So that's the one I want. Now if I press enter one more time, it'll be the lower left. And then you push graph. Now one thing this will not give you on the calculator, it'll give you the shading, give you the line, give you everything, except it will not tell you whether it should be a solid line or dotted line that separates the shaded region from the non-shaded. So you still have to use that. But that's how you do it by hand and on the calculator.